Okay, great. Thank you, everybody. The floor is yours.
Yeah, thanks a lot for giving me this opportunity to present this project on which is studying how to best incentivize countries to curb fossil fuels. So consider a hypothetical world with a single global institution tasked with curbing coal. Suppose it has an exogenous budget and that it can pursue three approaches. It can pay countries to reduce coal extraction, to reduce energy use, and to expand renewables. How should it best split its budget, assuming that it has complete information about all the countries' preferences and so on? I find that if all the supply and demand elasticities are finite, then it is optimal to allocate a positive amount to each of the three approaches. This contrasts with the landscape of existing international institutions aiming to curb fossil fuels. None of them pays countries for reducing supply. I'll argue that it would be beneficial to create a new and separate institution to fill this gap. This institution would initially define for each country in each year reference levels of cumulative coal extraction based on business as usual projections. It would then each year reward each country in proportion to how much their actual cumulative coal extraction is below the reference level. In the case of tropical forest conservation, such a scheme is already being used. It's REDD++. So for the first part of the presentation, I will consider the following static model, where I is the set of countries of the world, all assumed to be price takers in the world coal market. Country I chooses coal extraction, energy use, and energy generation via renewables. There's a global market for coal with the world market price denoted by P. I assume that coal and renewable energy are perfect substitutes and that there are no other sources of energy. So this is country I's net export of coal. Country I's utility is shown here. It gets concave benefits from energy use, incurs convex cost from producing renewable energy, and incurs a convex cost of extracting coal. Its utility is quasi-linear in money. This is its net coal trade revenue, and this is the reward payment that the country receives from the global institution that I'll explain later. I'm assuming here that the countries do not take into account the effect of their actions on global warming. Relaxing this assumption wouldn't drastically change the conclusions that I'll present. The global institution's problem is as follows. It initially announces a set of reward payment schemes. Each country takes these schemes and the world market price of coal as given and maximizes utility accordingly. I define a market equilibrium on a given set of reward payment schemes to be a combination of an allocation and a price, such that market clearing holds and individual rationality is satisfied, meaning that all of the choices by each country are optimal given its utility. So this market equilibrium concept gives rise to a map associating each set of reward payment schemes, associating to each such set a unique combination of a price and an allocation. This map is surjective. For each combination of price and allocation, we can find a reward payment scheme inducing it, and we can thus, within the model, view the global institution as if it was choosing a combination of a price and an allocation. Of course, in practice, it puts on the table these reward payment schemes, but in the model, that's actually equivalent. And this perspective of thinking of the institution as choosing the price and the allocation is very helpful for the analysis. The minimal required transfers that it has to end up paying the countries are given simply by the fact that countries always have the option of ignoring the reward payment schemes, and then they can just maximize the utility by engaging in the world market for coal and optimizing the energy use according to their own utility and also their renewables production. Now, the global institution cares intrinsically about the country's utilities, but it also takes into account the global climate change externalities that are determined by aggregate coal emissions. The global institution has complete information about the country's utilities. Its budget is exogenous and insufficient to induce countries to reduce coal emissions to the globally optimal level. In general, we can show that a price preservation lemma holds. At the optimal mechanism, the world market price of coal ends up being the same as in the absence of any mechanism. For an intuitive derivation of this result, consider the case where there are no renewables, so it's only about supply and demand of coal, and where all countries are identical. Here, Q0 denotes the quantity of coal used in the absence of the reward payment schemes. P denotes the world market price in this situation. And now suppose the global institution induces each country to reduce coal use and coal production to Q. Suppose the institution does it in such a way that it leaves the world market price P of coal unchanged. How much does it require to achieve this? How much money does it require? So in order for the representative country to accept reducing its coal use to Q, it needs to be compensated by an amount corresponding to the green area. And for to be willing to reduce its supply to Q, it's the blue area that represents the minimal required transfers. So now suppose the global institution were to implement the same allocation Q with a higher world market price of coal. In other words, suppose it were to aim for the same allocation Q, but with a stronger emphasis on rewarding supply reduction. We see here that the total budget that it would require would increase, since it's the sum of the blue plus the green. And similarly for a demand-heavy approach, leading to a reduction in the world market price of coal. So this argument can be fully generalized, including for our case with the renewable substitute. From this, one can deduce that as the available budget increases, so does the optimal spending on each of the three approaches. So here are the numerical results for the special case with constant elasticities on all the supplies and demands. So this is based on elasticity estimates taken from literature, social cost of carbon of $36 per ton of CO2, and using the fact that the current global ratio of coal to renewables is 6:4. It turns out to be optimal here for the global institution to spend 43% of its budget on supply reduction. And that's quite independent of how large its available budget is. So all the way up to the point where it can fully correct the global externality, which is this point here. It's always optimal to roughly spend 43% on supply reduction. So here's how the budget splits determines global welfare gains. So now just considering in general ways for splitting the budget between supply reduction, which is plotted on this line, and demand reduction, which is plotted on this line, it being understood that the rest is used for substitute expansion. So the corners here correspond to points where only one of the three approaches is pursued, and we see that this would involve substantial welfare losses. Around the optimum, the surface is rather flat, suggesting that it might not be so important to get the budget split exactly right. The important thing is to have each of the three approaches getting positive funding. So in fact, as long as each of the three approaches gets at least half of its optimal share of the budget, at most 10% of welfare is lost relative to the optimum. Now, let's consider a dynamic version of the model, where I denote by YIT, country I's energy use in period T, similarly for renewable energy production, and for the supply side, XIT denotes country I's cumulative amount of coal extraction by the end of period T. Country I's, so in each period, country I reads, again, concave benefits from energy use, incurs convex cost from renewables, producing renewable energy, and incurs a convex cost from coal extraction, which depend on cumulative prior coal extraction, as well as cumulative coal extraction by the end of the period T. This is a discrete analog of the assumption of stock-dependent extraction cost that is common in the continuous time literature. Country I's utility is again quasi-linear in money, and now countries discount the flow of benefits using the interest rate R. The global institution cares about countries' private utilities again, but it also takes into account global climate change damages, which are determined by the cumulative coal extraction by the end of the last period. The global institution announces a path of reward payment schemes and fully commits to it. As in the static model, I assume that countries take these reward payment schemes and world market prices as given, and that a market equilibrium emerges. At the market equilibrium, the global institution ends up paying the reward payment schemes, reward payments shown here on the left of this equation. And the budget constraints means that the net present value of these reward payments paid to the countries cannot exceed the net present value of the funding stream that the global institution receives. The price preservation lemma still holds in this dynamic case, so the optimal mechanism has to leave the entire price path unchanged. Here's what the spending path typically looks like at the optimal mechanism. There's positive spending on each of the three approaches in each period. And yeah, it turns out that that this is a general feature. Yeah, in general in the model, not only does the spending have to be strictly positive in each period, but we also have that as we expend the budget available for the global institution, the optimal spending in each of the periods on each of the three approaches has to increase. And so far, this is based on a very particular form of contracting, which is a quantity-based contracting. So we've assumed here that for each of the three approaches, the global institution defines reference levels and then rewards countries in proportion to how much better they do than the reference level. So for example, on the demand side, I've assumed that countries are simply rewarded to the extent that their energy demand is below the reference level that the global institution has set initially. And now, in practice, on the demand side, there might be better ways to incentivize countries. So instead of using a quantity-based approach, one could use a price-based approach, where countries could simply be rewarded to the extent that they price carbon. And it's simple to show here that in the model, the optimal mechanism on the demand side can be implemented through such carbon pricing reward funds. In fact, for the demand and substitute sides, to implement the optimum, the global institution simply has to reward countries for introducing carbon taxes throughout the economy. On the supply side, however, it's more complicated because we have this intertemporal linkage because there's a stock nature of the extraction, and also the prices are linked through the different periods. So practically, there might also be advantages of using a price-based approach. So one could have a carbon pricing reward fund that would reward countries to the extent that they tax the extraction of fossil fuel or exploration of fossil fuel. But it's not straightforward to see whether such an approach can implement the optimal mechanism on the supply side. But it does seem valuable because, at least in the first period, one can show that this approach can be used. And moreover, the most commonly proposed alternative form of contracting, which is a deposit purchase approach, can be shown to be insufficient by itself to implement the optimal mechanism. So, for example, Hastart in 2012 has developed a model where it's actually optimal to only rely on a deposit purchase approach, where a global institution would simply select appropriate fossil fuel deposits, buy them up, and pull them out of the market so that they can't be exploited. So to see why this can't be optimal if relied upon exclusively in this model, just recall the result I mentioned, that the optimal mechanism always involves strictly positive spending at each period on each of the three approaches. In fact, in the model, deposit purchase is equivalent to spending on the last period. So recall that here in the model, the global institution defines these reference levels for the cumulative coal extraction, and then spending in the last period corresponds to rewarding countries to the extent that the actual cumulative coal extraction by the end of the last period is below the reference level. And this can be shown to be equivalent to just buying up deposits. But
5 minutes left. Sorry.
Yeah, that's right. Yeah, and so we need, in addition to deposit purchase, which corresponds to the last period, we need spending on previous periods as well. So yeah, that's the main conclusion of the paper, that it's valuable to complement the existing demand side and substitute side approaches with a supply side approach, so to create a new institution for that. And yeah, and this finding that deposit purchase funds alone are insufficient to implement the optimal mechanism on the supply side is in contrast to previous results in the literature. So this suggests that it would be valuable to study in detail how carbon pricing reward funds can be used on the supply side. And so, time permitting, I could give some more intuition for why this result about the optimality of having a mix of all approaches, why this result holds in general. So the first observation is this price preservation lemma. That's the first ingredient in the proof. And then there's also a result which I call the monotone mitigation lemma. And this states that it's at the optimal mechanism, the cumulative coal extraction in each period is reduced. And as we move forward in time, it's reduced by more than in the preceding period, which actually means that the marginal extraction of coal in each period is decreased as we increase the available budget for the global institution. So intuitively, this makes sense that it's optimal to kind of spread efforts equally across all periods. And so this can be combined with the price preservation lemma to show this result that, which I call the monotone optimal spending corollary. So this says that if we denote here the optimal spending in period T on supply, demand, and substitute sides as a function of the available budget F, we have that as we expand the budget, spending in each period on each of the approaches increases. And yeah, to see why this is implied by the combination of the price preservation lemma and by the monotone mitigation corollary, we can see it as follows. So, so by the price preservation lemma, each country, in a sense, would yeah. So here initially we need by the monotone mitigation lemma, we need to pay countries to reduce already the supply that they provide in the first period. And as time progresses, there's this kind of overhang of all the coal that we have asked them to leave in the ground. And so we need actually to pay countries increasingly larger amounts on the supply side to keep the stuff in the ground. And by the monotone mitigation lemma, the marginal extraction in each period is decreased as we expand the budget. And that means that the demand, either the demand has to decrease or the substitute has to expand. And that requires spending on demand or substitute side. And it's always optimal to mix the two. So that's roughly how the proof goes. And yeah, with that, I'm looking forward to questions.
Well, thank you very much, Mr. Stern, for your presentation. So yes, now we have a couple of minutes. If anybody has a question, please feel free just to open your mic. Thanks. Okay, so no questions then? Okay, well then, thank you very much for your presentation, and then we'll keep up with the presentations now. If I'm correct, we have the floor is for Ms. Raphaela Kotsch.
Thank you. Let's share my screen.
Okay. Okay, yeah, we can see. Very good.
In presentation mode, yeah.
Yes, yes, it is.
Great.
Correct. Okay, well then the floor is yours. 20 minutes. Thank you.
Yeah, so thank you very much and good morning, everyone. I'm going to present a paper that I co-authored with Regina Betz, who is also present here in the session, and Peter Schwendner and Jan Abrell. I'm a PhD student at the University of Zurich and the Zurich University of Applied Sciences. And in this paper, we looked at the global trade of emissions reduction units and applied a network analysis. So I give a brief overview. This is like a brief overview of what I'm going to talk about. So how did this market work? So under the Kyoto Protocol, not every country, but industrialized countries committed to emission reduction targets. And then based on their baseline emissions in 1990. And then they received assigned amount units, which reflect the allowable emissions according to their target. So for example, this is hypothetical. If a country has a target of minus 21% reduction, it would receive for a period from 2008 to 2012 these 79% times 5 emissions allowances, these assigned amount units. And if the emissions were exceeded during this time frame, they could buy additional AAUs, these assigned amount units from other countries, or other types of certificates such as CRs and EIUs. This is just like a brief intro to the Kyoto Protocol. So the Kyoto Protocol actually defines 3 different types of carbon markets. One was these emissions trading with AAUs, and then also the clean development mechanism, where countries and developing countries could host projects and that could generate CERs, and that could be used by industrialized countries to meet their climate targets. And then we also have joint implementation, where we will focus on here in this paper. And here the specific is that these are really projects that could be only done within industrialized countries, who also have climate targets. And they had to exchange AAUs for EAUs generated. So at its best, this EAU market was like a zero-sum game, since it was exchanged. And the initial idea was that countries with own commitments would invest in projects that are cheaper than their own mitigation, would go to other countries and generate offsets there for the compliance. But what we could actually see in this market is that many countries or host countries actually just develop their projects without any involvement from outside of their country. And also what this implied is that we actually could see that regional emission trading systems like the EU ETS were like indirectly linked with other ETS through this use of international certificates. And also this involved that new market participants that were not really intended participated in the market. So companies that have to comply within these regional markets. And we assume that they have different interests and preferences than governments that need to comply with their Kyoto targets. So why do we focus on ERUs? So first of all, there's not really much research. There has been a lot of research on the CDM and other markets, but for the market for ERUs, there's really a lack of understanding how this market functioned. And then we have the advantage that this market is now over, so we can see an entire market from its beginning to its end. since in 2020 the Kyoto area was over, and yeah, and then the third reason is, maybe that's the most important one. So currently discussions under the Paris Agreement still going on about whether we will have a new global carbon market under the Paris Agreement. And if this would be the case, then this potential new carbon market would be, from its structure, the closest to the GI market, since also under the Paris Agreement, all the parties involved would have their climate targets, and then due to this different level of ambition of their climate targets, there could be potentially also hot air in the new market, which was the case in the GI market. So this hot air refers to the fact that that there was this incentive, since you had to exchange AAUs for EAUs, that countries with a surplus of AAUs really were trying to sell non-additional or not very good quality products, good quality certificates from bad projects, I'd say. And that another problem was that governments did not really have, were not really involved in a decision which EAUs they would use for their own compliance, and they would just use whatever ended up in their surrendering accounts. So what companies in their regional ETS would just surrender. So they don't really actively participate in the market and would maybe choose based on quality of certificates. So most EAUs come from Ukraine and Russia, so very large part. And it's assumed that, like often in this context, we hear the term hot air, that these certificates were not really valuable emission reductions. And this has also been shown in studies that a large part of EAUs actually are very problematic, and the additionality of these projects are questionable. So the integrity of the market is questionable if countries or companies use these certificates. Existing studies, there are few studies on the GI market, but they don't really assess the whole period, and they also don't look at the registry level. And then there are also network analysis papers, mostly for financial markets, but there are also a few studies on the UTS, but none really combined different data or looked at the international market. So we want to fill this gap, and we want to look how a trading network would look like in the regional markets for the specific type of certificate. And then we want to see who is actually playing a role in this trading network, like how do EAUs come from its host countries to the entities that use them, and who is involved, which countries, which sectors. And our hypotheses are that seller countries like Ukraine, Russia will play a major role as sellers. And then those that use EAUs will probably, it will look like that we have only like few transactions, like from the project host to those that use them. And then if sectors are involved, they are probably very familiar with this project types, such as companies from energy industry or financial institutions that are also involved in other markets in the trading. So our framework is a network approach. We built a network where the nodes are the traders, and the links between the nodes, like the edges, are the trades. And then this is a directed network, and we weight the links by the volume that's been traded. And then once we have the network, we try to we quantify the roles of the nodes within this network using centrality measures. So these are 5 centrality measures that we use. The degree centrality, so this is just a measure of how active traders are in the network. It's the sum of in and outgoing trades. but also we consider the out degree centrality and in degree centrality, so only looking at the supplier or demander of ERUs. Then we use the between centrality, which is a measure for each node. It shows what's the number of shortest paths that pass through this node. So it's a good indicator of key brokers in this network. We also look at the eigenvector centrality, so which is a good measure of the influence on the trading network, since it also takes into account the importance of the connecting nodes, and then the authority centrality, which also takes into account like if a node is very well connected to other trading hubs. And with these centrality measures, we will have we have a good understanding, or we can characterize these different roles and measure them. And then we perform simple or less regressions to test or to see if there's a relationship between the characteristics of the traders and their role in the trading network. And we do separate regressions for each centrality measure and for both commitment periods. So on the data we use, and this is very novel, is we combine registry data from different ETS. So we use the EU ETS trading data and from Switzerland, and this is the most recent updated data that goes up to 2018. And we matched this registry level data with the Orbis database to get the sector affiliation of the different accounts in these registries. We know which firm belongs to these accounts and which sector do they belong to. And then we also have information on the project. So we know not only like if an EU has been traded, but we also know which type of project, where it comes from, which host country it's coming from. So we also have this information. And then this is how, I hope you can see this, it's not too small. I'm afraid I can't really zoom in, so I just try to describe what you could see. So this is like a network we would probably expect. So this is for one project ID. The network we see, it comes from Ukraine. It goes to a Swiss voluntary account. So this yellowish color means this is a voluntary account. And then it spreads to different other central accounts, and then trickles down to this light blue mandatory accounts in the EU ETS, and then ends up with the dark blue government accounts and the European accounts. So this is probably surrendering of these certificates. And then we also have project networks where it's really messy and it's hard to understand where it's coming from. It's probably coming from also from Ukraine, but then it takes rounds and there are many people involved. It goes to Switzerland, goes back to Europe. So where it's more complicated to really understand the roles of these different traders. Yeah, this is like a description of the network we have in the end. Yeah, for the network, we actually excluded all these administrative transfers like surrendering, but also conversion of different types of the ERUs, and only concentrate on the trading. And this is how like an aggregated network over the whole period, Kyoto period, looks like. So the color indicates the sector. Blue is the financial sector. This dark red is the wholesale and retail trades, the commodity traders. And yeah, you have the country codes in the nodes, and the thickness of the edges indicate the volume traded. And we filtered this to accounts which traded more than 50 times within this long period. And then you can see that from Ukraine, the trade starts, and then Swiss wholesale sector plays an important role, and the financial sector in many different countries plays an important role, but what we can also see is that what was a bit surprising for us is that this is Jersey, so the Channel Islands play also an important role in this network, and these are only 4 accounts in a network of several thousand accounts, and these play also an important role. So this gives us an indication of what we can expect. And this is the outcome of our regressions. So each figure shows one set of regressions where we have a different centrality measure as a dependent variable. And the reference region here is a combination of countries. Compared to this reference region, we see that Swiss accounts are very active in this market. So this is the in-degree centrality, but we also see that that's probably not so surprising. A lot of Ukrainian countries accounts have a high out-degree centrality, and then what's interesting is that really this is significant that Channel Islands, so Jersey and other Channel Islands, play a really important role as broker and intermediaries. So their between the centrality is really high compared to the other regions, and also
5 minutes left. 5 minutes left. Sorry.
I think this is clear now. And then for the results for the sector, it's the same approach. We here see that as we expected, that the financial sector plays an important role in this network. So it's both for in-degree, but also for out-degree, significantly high, has a high impact or has an important role. And also what we would have probably expected that the effect is a bit greater, but also the commodity traders have a significant role in this as they have like a high degree centrality and also a high eigenvalue centrality. And so I already come to my conclusions. So we could see that EAUs were mainly generated by countries with an really excess of AAUs, such as Ukraine, Russia, were hinting us at the conclusion that this is probably hot, or a lot of them are hot air. And what we could also see, what's really surprising, is that companies really use accounts in jurisdictions that are not very well regulated, or where there's a minimum of legal regulatory requirements, and that we see so many long trading chains that involve Jersey and Switzerland, and that are outside of these main issuance countries or surrendering countries. And then we see that the financial sector, but also information communication sector, and the commodity traders play an important role, especially in Switzerland. And that's something what I often hear at the COPs, that when we talk about the new carbon market, oftentimes people say, but doesn't matter if it's not so stringent, and maybe there might be hot air in this new market, but no one will use them, no one will dare to use these bad certificates. And actually we can see here, if there's hot air and if there are bad certificates, it will find its way into the system and it will be used. And this has a negative impact on environmental integrity of the market. So when we include offsets in the market, we need to include also limits for these certificates in the regional and national ETS to ensure that they are supplementary. And with this, I conclude, and thank you for your attention. I'm looking forward to questions.
Okay, thank you very much, Ms. Kotsch, for your presentation. So yes, now we leave the floor to some minutes to some questions that someone may have, please.
Is there a way to estimate how much in terms of financial fees are accruing to these intermediaries? This could be like interesting to, if we compare this kind of approach to mitigation with other approaches. If we can reduce the cost.
You mean the rationale of different traders to use brokers?
I had in mind, what's the total revenue that is accruing to all the brokers and financial institutions through the market, and then to put this in relation to the volume, the value of the certificates, like what percentage does this constitute?
Yeah, I think that would be super interesting. I'm not sure if it's how to measure it, since price we only have like the daily prices, but we don't really know how much has been paid for each trade. But it looks a lot like a lot of trades look like there has been speculation, so there must be some advantage or benefit from these brokers to participate in this market. But yeah, that's something like an interesting question I will think about, how to address this in this network. Thank you.
Okay, any other questions?
Yeah. Is there a way to get some kind of willingness to pay for environmental integrity? Could you identify which sectors maybe that have more of a public relations aspect to their offsets and so on are willing to pay for better ones?
Yeah, that's actually the next step we want to do, to see also since the compliant companies in this market, they have a choice between different types of certificates which come with different qualities and different prices. So I think this would be the next step, to look at the choices and the willingness to pay. Yeah, I think that's a good question. I think it points to the direction we actually want to take. I mean, here we just focused on building this network and see if it's stable and what we can see first. And but in this willingness to pay approach, probably makes more sense to include other types of certificates to really see what people are willing to pay for a good quality certificate and a real emission reduction. Yeah.
Thanks.
Thank you.
Okay, thank you very much. Any other question? Well, okay. Thank you then very much, Ms. Kotsch, for your presentation. Now we'll keep on and we'll welcome Ms. Thais Nunez, Rocha.
Hello, thank you very much. Can you hear me well?
Yes, we can hear you well.
And
but,
can you see my presentation?
Yeah.
Okay, perfect.
You are not right now in the full screen mode.
Is it better now?
Not really. We still can see your document.
Let me see. So it looks kind of weird. So.
Okay.
Just 1 second.
Yes, don't worry.
Okay, probably like this. What about now?
Okay, it's loading. Yes, I guess now it's correct. Okay, so the floor is yours, 20 minutes. Thank you very much.
Great. So thank you very much for being here and for these great presentations. So I would like to start saying that this is a co-author work with Magda in University Wittenherdecke. And this is part of a big project that started in 2016. It was the end of my dissertation, where I was working up with trade and environment, always interesting myself on these issues. And I actually realized that environmental regulation could have an impact, especially that is something that requires less infrastructure to be done. Okay, yes, we need some enforcement, some good institutions, but this can be achieved more easily than big infrastructures. So there were some byproducts of this research, and now we are trying to build together with Magda a really nice setting with some more sophisticated data of it. Okay, so I will present you for now. This is a preliminary work, what we have found so far. And the big question that we want to answer with this paper is, does this stringency in environmental regulations improves environmental quality? Okay, this is the main question. And also we want to give some light in the what we can learn also about the effect of this environmental regulation on trade. Okay, a bit as an indirect porter hypothesis. Okay, so I will just go directly to some more directly linked literature. If you want more a broad literature about trade and environment, I also have this at the end in appendix, but since we don't have a lot of time, I will go directly to the more interesting and more linked subjects. So we know from the paper of Brunel and Levinson that capturing environmental regulation is a really challenging task, because it's a multidimensional thing that we want to capture. And we have some empirical papers that have done so. The first one, Frankel and Rose, 2015, they did it for a given year, and actually they tried to capture this idea of institutions or environmental regulation with the quality variable. Also, we have a second work where they use also polity as a proxy of environmental regulations. They say it like this. So Frankel and Rose talk more about institutions in general. So the second paper, they say, okay, we can control such as environmental regulations, such as polity too, with such a variable. And then we have the work in 2015 of Tsurunumi, where he investigates with the co-authors the effect of environmental regulations on bilateral trade. Okay, and they use abatement cost. Okay, so they are different empirical applications, either trying to observe what is the effect in the environmental outcomes, such as the two first works, or either in trade. Okay. And then there are two byproducts from my dissertation, where I created this big data set about the environmental laws, national and international laws, from a bunch of countries from 1830 until 2050. Okay, so I did two works with Inma and with Camilla about using national laws and seeing what is the effect into local pollution, and also using treaties, international laws, and seeing what is the effect in trade in fuels, the trade of fuels in general. Okay, and the idea that we thought with Magda now in this project was to use the stock of laws and the treaties as a country environmental leg. Okay, and I will show you this with some illustrations, and you will understand why this is important. Okay, so what we thought is not only important the fact that countries start to do these stringency environmental regulations when they are increasing the laws or the treaties in time, but also it is important what has been done in the past. So this is the environmental leg that we call it. Okay, and this is going to fulfill the emptiness that we have in the fact that we have an absence of comparable measures across countries and over time. And also we are not going to use other type of variables that have been used in the literature as proxies that will be misleading or contain more hidden effects. Okay. So what we do, we create a new measure of a number of legislations and treaty by topic. So this is an environmental regulation that is called de jure. Okay, and is composed of the stock of these laws and treaties plus the number per year. Okay, and now unluckily I don't have still these results, but we are working in an extension of this, reading with big data techniques the text of these laws in order to do more sophisticated analysis using what is exactly written in this laws. Okay, so this is something really exciting, but so far I have just this talk and the laws, so keep tuned for the next paper. And what we evaluate is the impact of environmental regulation on environmental outcomes. And more precisely, I will present today the particulate matter 2.5 exposure. Okay, and we did it also for other gases and also for forest area and other environmental outcomes, but I think the more relevant ones are those that we found in PM 2.5 exposure. And we try to give a straightforward answer about the effect of environmental regulation on trade. Okay, as I said before, this supported hypothesis, GDP trade effect. Just I didn't see the time. At what time did I start it?
Yes, 1 second. You have still, well, it's 7 minutes only. Have passed already, sorry.
Left?
No, it's been 7 minutes.
Okay, okay, perfect.
Yeah.
Thank you.
I will let you know about 5 before, okay?
Thank you, perfect. Okay, so the outline is as follows. So I will present some stylized facts that I wanted to show you. I said some illustrations about what are these laws and also how this particulate matter it's behaving, and I will present the methodology, the data, the results, and some conclusions, and also what we have found as further work for this paper. So if we look at the evolution of particulate matter emissions in time, and we see the mean in the last 15 years, we can see that it's something that is increasing. Yes, we know that at the end, we have a slow decrease, good news, but still in the last 20 years, it's been increasing, okay? And if we observe, other local emissions or emittents, we have SO2 and O and NOx, we see that also they kind of still increase in time. Okay, we saw all of them, they have a small decrease at the end, so we hope that this will be a trend, but so far there are a lot of these gases present in the nature, and that's why we still try to find a way to stop this. If we look at the map of particulate matter in 2015, we can see where they are mostly located. So we can see, with no surprise, India, China, and Indonesia are the most intensive countries, but there are also some parts in South America and Central America and North America and Africa and some parts of Europe. Now, this was about emissions, okay? But now we have also a variable of the world development indicators that is particulate matter exposure. And this exposure is exceeding the WHO levels. Okay, so this is something that is even more critical than the emissions per se. And we can see that have been efforts in the last 5 years that decreased this of more or less 5 points, but there is still a really high, the mean of these gases that population is exposed. Okay. So this is the one that we are concentrating in this paper. So I have done regressions with all of these variables, but I will present you this one because I think is the more relevant one. And another thing that I want to show you, so I will show you this map of the world of this particulate matter in the last 5 years. Again, is the exposure, the population exposed exceeding the limits of WHO. And as we can see, this is the map in 2000, and then this is 2005. This is 2010, okay, and this is 2015. And as you can see, there is not a lot of changes. Yes, there are some regions that became more clear or more clean, but still there is a big problem in this region, okay, and they are still really high. So this is something that we should pay attention to. The methodology that we use in this paper is as follows. So our explained variable is going to be the environmental outcome. In this specific presentation, I used the local air pollutant particulate matter exposition. And this comes from burning of fossil fuels in the vehicles, power plants, or other various industrial processes. As explanatory variables, we have trade as a share of GDP, the environmental regulation variable, an enforcement variable that we use government effectiveness, environmental regulation interacted with trade, and how we construct this environmental regulation variable. So we do it as a counting variable, because the idea is that we want to capture this intensity environmental regulations as the strictness of regulation. Right? So we have a composed indicator that is going to have the past laws. So in the case of this paper, it will be from 1830 until 1999. And then from 2000, we would just add the new laws per year. Okay. And we use laws in subjects, in this case, for like air and atmosphere, energy, environmental in general. And when we use also other environmental outcomes as forest area, we have forestry and so on and so forth. So how does it look like this environmental regulation? So more or less like this. We have an increasing number of regulations that are have been passed in the last 20 years, and I separated for non-OECD countries and OECD countries. But if we inspect a bit further, and we separate this legislation from the treaties, we have these two. Okay, we can see that there is a kind of a second derivative of the treaties that would suggest that would be negative, but in the case of legislation, it's still increasing, it would be positive. Okay, so these differences between these two are something that are really interesting for us. I think also that when you have treaties in general, what we have learned from treaties is that they kind of impose new laws inside of the country. So it's normal that we have kind of guidelines from the treaties, and then that we pass several laws. That's why we have more in the national level. Okay. And this will also kind of explain why we have these different shapes. Okay, this is still increasing, and then we expect, I don't know, probably in the next 30 years, that it will become kind of more similar to treaties. Okay, but what I really find interesting to also being capturing in this paper is also what happened before. before 2000, because as we can see, it's really interesting information that we have here. So if I place here the year 1900 and here 1950, okay, we know that in this last 50 years, in the two cases, there is a lot of important information that will represent what I said before, the environmental regulation lag that countries could have, okay? And this is what we want to exploit in this paper. And the model at the end that we are estimating is as follows. So we are going to use the determinants of pollution. We will have here the environmental outcome explained by trade, environmental regulation, the interaction of them, and other control variables. Okay. And for the second question, we will have trade explained by environmental regulations and other control variables to see if the Porter hypothesis have a straightforward answer or not.
Sorry, there are 5 minutes left.
Thank you very much. So the data that we are using, so I will go really fast on this. We have 169 countries. The data comes mainly from the World Development Indicators, and we have also data gravity and BASI from CEPI, and the laws that come from EcoLeaks, that is a platform created in a joint effort from the United Nations and the FIO. The results. So I will present some tables and I will just comment on the main results if you want to discuss later on or afterwards in the questions part about more specific things. So please let me know. So as we can see, laws in this case, so I have used the three laws, energy, air and atmosphere, environmental in general, and here we have all the countries, and we use in this part the last three columns all the controls. Okay, here we have just the laws and their interactions with trade laws and interaction. And as we can see, so they decrease pollution exposure, in this case particulate matter exposure, and this effect remains when we control use different controls. We have GDP and GDP square with the usual signs and significance, and this is when we use all countries. Okay, but when we use just OECD countries, we see that this effect is exacerbated, is even big, but we also see that the countries that trade more also will be less exposed to this pollution, and is normal because they can have better regulations and enforcement in order to protect to this from this. And also we see that there is a kind of an independent role that will play the trade and the regulations in this case. Okay, and for non-OECD countries, we have almost no effect. We can see that just in environmental general subjects type of laws, we have an effect decrease in pollution. And it looks that yes, it could be related also to trade, but the single variable is not significant. So still efforts to be done. Remember in the map, the main part where this problem exists is in developing countries. So we need to do something in order to solve this problem. Probably there is a key here, but we should develop more and know better. When we see the treaties, we can see two things. First, some of them decrease pollution in general. So we can see energy, but this effect is not remaining after using the controls. But we see that it could be a possible positive effect into trade. Nevertheless, what I suggest is, discussing with Magna, we should use some kind of simultaneity controls in order to see if there is not endogeneity effect here. Okay, so this is part of our further work that I will present afterwards. when we see OECD countries, we can see that them can have an effect decrease in pollution, these laws. Not all of them. Environmental in general seem to increase pollution, but the other, air and atmosphere and energy, could have a decrease in effect in this exposure. And in the case of non-OECD countries, we can see that first, there are better results than with the laws. Okay, so it looks like treaties are better respect. But nevertheless, some of them can also increase the same like before. Subjects such as environmental in general could also increase pollution. Okay. And again, we should inspect further this simultaneity issue. And now I will show you two tables, one from legislation and the other from treaties, in order to see the effect on trade. And what we can see is that energy laws could have an effect positive to trade. Okay. Yes, a positive effect on trade. And in the case of the treaties, they could have also an effect, but it will be negative, and also environmental general issues. And the only thing that could be possible is positive will be air and atmosphere. And again, we should inspect further this simultaneity issue in order to see if this could explain the positive results, or if this is only something that we should inspect further with the big data techniques. So the conclusions and the further work, environmental laws improve environmental outcomes, still depending on the type of law and the type of country. And this is particularly true for energy and environment in general and for OECD countries. Treaties in air and atmosphere and energy subjects decrease local pollution, especially for OECD countries. And the laws and treaties seem to play an independent role, with trade as for decreasing particulate matter exposure. Okay. Laws on energy subjects appear to be beneficial to trade. Still, we have to inspect further, I say this afterwards, the possible simultaneity. And on the contrary, treaties on energy and environmental general subjects appear to decrease trade, but this is not the case on treaties with the subject of air and atmosphere. And for the further work, inspecting possible simultaneity between environmental regulations and environmental outcomes should be done. And also, we think that separate the stock from the yearly regulations to further study the difference between these subjects, and also the difference between countries, and knowing what will be precisely this effect of the lag will also be interesting. And as I said before, we would like to go further with the text of the laws in order to analyze in depth the strictness of environmental regulation variable used in this paper and give more precise policy recommendations, particularly for the non-OECD countries that are the more concerned with this. So that will be it, and I will be more than happy to listen to your comments and your questions and everything. Thank you very much.
Thank you very much, Ms. Nunez. So yes, now we leave a couple of minutes for any questions that might be there, please.
Is there any data on stringency of enforcement, things like of the environmental laws? And also, do you think this is good? This is an important explanation for your finding that that you presented.
So yeah, so
that in developing countries maybe they have not good enforcement.
Yeah, exactly. So precisely this is that will be the gap, right? So we have the laws, the jury environmental regulations, and then what happens in between the moment that these laws are really applied would be explained by the enforcement. So we don't have, in my knowledge, we don't have precisely information about this. I think we could probably inspect, you know, kind of the legal procedures done either internationally or either nationally. We have some of this information in our data. But what I will like to do is actually one of my projects that exist as a byproduct of this is I would like to see what is the actual quality. So, you know, measure the difference between these laws that have been passed by subject and actually the result of this, I don't know, lagged from 1, 2, 3, 4, 5 years. So that would be something interesting to do, to see this gap between the enforcement and the laws as environmental regulation. I don't know if this answers to your question.
Yes, it is. Thanks.
Thank you for your question, Lennart.
Okay, any other quick comment, question?
I have a small comment, and thanks a lot for your presentation. I find it really great. My small comment rather than a question is that these results that you showed us really reminded me of the research by Shapiro, and he presented in the American ERI his very similar results, but based on a combination of causal inference and a macroeconomic model, and for the US. So I really like this because it's very consistent with results of, you know, what has happened in an individual country. He presented results from the US, and and I was wondering if also with this data you mentioned at the beginning, but maybe you could also you know, do some machine learning and kind of learn what are really the drivers to try to disentangle, you know, what are the drivers? Is it really kind of like the laws, or is it efficiency playing some role in this, and you know, efficiency of new technologies and so on? And this would be kind of very similar to Shapiro's analysis, only that in your case you have, you know, the panel of all countries.
Yeah, thank you very much for this question. Actually, this is like my dream from the last 4 years, and now we are approaching this kind of data. So it's been a complicated year for all of us, but particularly for Magdalene, that we are young mothers. So you can believe that these efforts have been really, really precious. And we are not far, actually. We are creating exactly this machine learning with some big data techniques. And we have been facing a lot of problems, but at the end, what we will have, it's precisely what is inside of the laws. Because when you read the laws, we can see that actually they are either really precise and they give you really keywords that will show that something will happen, and others that are rather vague. So when we can split those and really focalize with those that are really, really precise, and that we can expect of them an effect, so I think we can have more interesting things to say, more precise, and as I said before, we can give a more rich policy recommendation, particularly to developing countries, because yes, it's really important to work with also developed countries, because they give us a kind of an idea more rich with the data that they have. But I think that now the big problem are those that are suffering from this pollution, and those are developing countries. That's why I interested myself in this subject. I don't know if this is okay about your question.
Yes, thanks a lot. Thank you.
Thank you for your question.
Okay, thank you very much. Something else? Okay, then thank you very much, Ms. Nunez. Now we'll pass with our last presentation of the session, Mr. Hannes Hobbie. Is that correct?
Hannes Hobbie.
Hannes Hobbie.
Yes.
Sorry, yeah. Okay.
It says that I don't yet have the permission.
Okay, maybe. Okay, let me check here. Maybe.
Now, I think now it should work.
Yeah, because it was, we had the other presentation, right?
Yes,
okay, Hannes.
So
there
now
you go.
Should see my presentation mode, right?
Yeah, it's showing. Okay.
Yes.
So then the floor is yours. Thank you.
Thank you very much. Yeah, as I said, I'm Hannes Hobbie, and I'm research associate at the chair of energy economics at the TU Dresden. And what I'm talking about is a joint work together with my colleagues Karl Philipp Anke and Steffi Niskunel and Dominic Merst, who is the professor at our chair. I'm talking about interactions between international and national carbon mitigation policies. And at first hand, a little advertisement. So as we already submitted this work to the last year's IAEE conference, we proceeded in working on it and had some improved results and already published this work at the Energy Policy Journal. So what I'm talking about today, you will find to an extent in this paper also, and what I'm showing now is building on it. As you might know, the European Union emission trading system constitutes one of the core instruments in the European Union climate protection policy. But however, some member states have also introduced national carbon mitigation policies. These comprise renewable energy expansion strategies, for instance, energy efficiency measures, but also coal phase outs, meaning that large stacks, generation stacks for electricity running and coal and lignite are gradually phasing out of the member states' generation fleets. So we apply here a fundamental market model, which distinguishes from what we've heard before, to examine to what extent these national policies affect the effectiveness of the EU ETS and to what degree this impact is reflected in European Union allowances prices. So in other words, carbon certificate prices. And we see that, and I will show this in a greater detail in the following slides, that renewable expansion has not a very strong effect on carbon prices, but coal phase outs, as I mentioned, they really have a strong price suppressing effect, affecting the prices in a way that they not provide sufficient price signals for the desired decarbonization levels anymore. Just a brief illustration on how the emission trading system works. It's a cap and trade system, and it's displayed here in this figure. So we've got a linearly decreasing emission cap, and we got different, let's say, carbon sources. Emitters need to buy tradable certificates. So the regulator somehow needs to assume a good reduction rate that that is providing price signals to generators and stimulating them in changing their technologies towards more climate-friendly technologies. But there's a lot of uncertainty in assessing these reduction levels, since as I said, some countries decided about a coal phase out, so this is changing the structure of the generation fleet. Also, there's uncertainty about the operation time of existing generators, and also the production itself of conventional plants, but also of renewable plants is subject to some uncertainty. So taking this all together, it's quite complicated to have a good estimate on which reduction rate is really providing a good price signals to the market. As a result of that, and you might know this, during the different phases of the EU ETS, we had continuously adjustments, and this involves the reduction rate, which was increased from phase 3, which had a level of 1.74% to 2.2%. We introduced some other, let's say, instruments, backloading and the market stability reserve, that provided the regulators with additional flexibility in sort of adjusting the cap, and with the newest phase also canceling of certificates. So also the question arises how much certificates should be cancelled, or if they should be cancelled at all or not. When we start research, we look at the literature, of course, at first, and this is a collection which is also part of the paper. We grouped these literature sources to two groups. Firsthand, if they either included AUR prices, carbon certificate prices, as exogenous inputs into their analysis, or if carbon prices were sort of endogenous model results. And then we looked if national, also in addition to the European ETS, national mitigation measures were included in their investigations. And then here we differentiated between non-measures that were included, a coal phase out or renewable extension included, or a coal phase out and like both instruments or both measures included. And as you can see, I mean, I would not promise that this is complete, but at least there's only very less works in this field up in the right corner, which is the reason why we addressed this topic. As I said, we applied a fundamental power market model, and this is called ELTROMOD, which we use in several studies at our chair. Fundamental means that we have the entire power system infrastructure included as a database. So ELTROMOD runs on a quite extensive power plant databases. This allows us to model dispatch decisions of single power plants in a very detailed manner. So the model minimizes the total system costs that occur in providing the electricity load of each country in each hour with electrical power. And we included several countries here to cope for trade and effects of trade. Trade is constrained with hourly so-called NTC values. We included a lot of different generation technologies. For some countries, these technologies are modeled blockwise. For some as technology-specific aggregates, we got also storages in the system. And as I said, the demand is modeled hourly resolution for 8,760 time steps of the year. In addition, we included a carbon constraint, what we call carbon constraint. So the total carbon emissions are limited to a specific value, and with this constraint, we can take then as a result the dual value, which is sort of reflecting carbon allowances prices. Further model outputs are the power plant dispatch, exports, imports, renewable curtailment, and also electricity prices that you can derive from the dual value of the market clearing balance. So we took this model, updated it, and created some sort of scenarios. So we have here two projections into the future, 2025 projection and a 2030 projection. And the projection basically determines the values of electricity demand that are included, PV installations, wind installations, and also the assumed linear reduction of carbon emissions. And then we ran three different scenarios for each projection: a no coal phase out scenario, and this is sort of a counterfactual case since countries have already implemented a coal phase out or started to phase out coal technologies. Then we have the scenario that includes the coal phase out according to national plans. And then we have a third scenario that assumes a coal phase out. And here we additionally canceled certificates of the available certificate pool. So let us have a look onto the results. First, the scenario with no coal phase out assumed, so the counterfactual case. These are model outputs, as I said, and here you got on this axis the total carbon emissions, and you see here that, of course, since we apply a reduction rate, the carbon emissions decline. And here you got the carbon price, the emission EUA allowance price as the model output. And the axis on the right-hand side is showing the exact levels. So what you can see here, even with no coal phase out, assumed prices increase, though we assumed also a renewable expansion. So from this, we conclude, so under the current design, and current means to the date we conducted the analysis, renewable expansion does not drive down EUA prices. Yeah, as I said, even though not considering coal phase out prices increase. So then looking at the coal phase out scenario, similar figure in this style. We have got here the total emissions, and now we highlighted the EUAs, so the certificates used by different fuel types from the generators. And as you can see here, for the 2025 projection, we already see that there is some sort of excess certificates, meaning that the carbon constraint is not binding anymore. And this in turn leads to a carbon price of 0. So without any cancellation of certificates, we can see here that the coal phase outs in the member states countries, those countries who have decided about, undermines the effectiveness of the EU, since it's not providing any price signals anymore. So let us look now onto the scenarios with cancellation. And I know that this slide is quite packed. First of all, we got the two projections again here. So the projection for 2025 year displayed with triangles as marks, and then for the 2030 year with squares as marks. At first, I just want to talk about those triangles. And then we ran different cancellation strategies. In this scenario, we canceled certificates that have, let's say, or we replaced coal with gas, and replacing those technologies leading to reduction of emissions by 50%. Which we assumed here. So this is what we call a sustainability factor, 50%. So 50% of the, let's say, avoided emissions of coal are going to taken out of the system. Here 30%, here 40%, here 60%. So it's somewhere in between here, 30, 40, 50, 60. Up here you see the carbon prices, the AUR prices, model outputs, and here you see the emission intensity, emission factor. It's basically emission intensity of the residual load. So it's basically the intensity, the carbon intensity of those plants, those conventional plants, which are also part of the ETS to serve the electricity demand. So let us compare now in the beginning those two scenarios. Again, the no coal phase out and the coal phase out scenario. And what do we see here? This was the price with no coal phase out assumed, and the price drops down to a value of 0, but the emission factor stays at a rather constant level. And this is what we all say about literature also denotes to as the waterbed effect. Since the cap stays at a constant level, emissions are going to take place in other countries, in neighboring countries, but prices drop down to zero. So if we now cancel certificates, we can sort of restore the capability of the EU ETS to incentivize carbon mitigation based on price signals. So this triangle here is the 50% model run, and we have here a EUA price of 48 almost, and these of the remaining runs. So with a stronger degree of canceled certificates, we see here that prices increase again and the entire emission effector of the system declines. So in turn, we can say that the cancellation can restore the capability of the EU ETS. And you can see this also in the generation shares that I displayed up here. So this is the generation of the conventional power plant fleet displayed here. We distinguish here between coal and lignite. It's grouped as an aggregate, gas and other conventionals. And as you can see here, with higher prices, the amounts of gas in the generation increase and the amounts of coal and lignite decreases. So basically, we see that the ETS would function effectively again.
5 minutes left.
So, yes, thank you. Summarizing. So we see that the EUA prices are strongly affected by fundamental market forces, and these include the renewable deployment strategies of national countries, coal phase outs, other national emission reduction strategies, but also the assumed emission cap. And I can say from my experience that model runs are very sensitive. So slight changes in one of those variables will have a large impact on the price. We saw that national carbon mitigation policies can thwart the ability of the ETS to generate price signals for carbon mitigation, not necessarily for renewable expansion, but as we saw for the assumed coal phase outs, a cancellation can stabilize EU EUA prices, but a cancellation needs to be done very carefully as your prices react very sensitively. So altogether, I would say it needs a good and better, maybe also better coordination of national mitigation strategies of single or individual member states and the European Union environmental policies. Thank you very much.
Okay, thank you very much, Mr. Hobbie. So is there any questions, please? Okay. Well, if there are not any more questions, I would like to first to apologize for the little delay we had at the beginning. And well, thank you all of the speakers for your presentation. Please do not forget to upload your presentations in the dashboard. And well, that will be all for me. Anybody wants to add something else?
Thanks to all speakers.
Okay. Well, thank you very much to everybody. Have a nice day.
Thank you. Bye.
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 Bye.